In this video, we're going to learn how to process the results of an experiment where we'll be measuring the heat of combustion of some fuels. And we'll also look at some other problems involving heat of combustion and enthalpy of combustion. Okay, first of all, this diagram over here shows an experiment that we're going to do in class when we're back at school. There's also a video linked to your OneNote that actually demonstrates how the experiment is carried out. The basic idea is that you use a spirit burner. So you've got the burner, and the first thing that you need to do is you weigh the burner. Then we've got a metal can, and the metal can contains some water. You need to know the volume of water in the can, and keeping in mind that 1 milliliter of water weighs 1 gram. So if we know the volume of water, we also know the mass of water that is in the can. We use a metal can because it's a really good conductor of heat. And you can see that we've got a thermometer in the metal can, and that is going to be used to measure the temperature of the water at the start of the experiment and after the fuel is burnt. Okay, so we know how much water is in the can, we've weighed the burner, and then it's just a matter of lighting the burner and allowing the fuel to burn for a period of time. It actually doesn't really matter how long you let it burn for, just allowing it to burn for a period of time. Okay, after that you blow out the flame. You need to weigh the burner again, and the mass is going to have decreased because some of the fuel has burnt. Okay, so you can see that's an example of the sort of data that you might produce in this experiment. So first of all, by weighing the burner before and after, you've got the mass of fuel that's burnt. So in this case, we've got 0.355 grams of methanol that has burnt. The amount of water in the can was 100 milliliters, and the temperature of the water rose from 20.25 degrees to 37.65 degrees. Okay, so Q is equal to MC delta T. So the mass in this case is not the mass of the alcohol, it's actually the mass of water. So since we've got 100 milliliters of water in the can, the mass of water is 100 grams. Now, keeping in mind that on the data sheet, the value for the specific heat of water is given as 4.18 times 10 to the power of 3 joules per kilogram per Kelvin. We need to have that mass given to us in kilograms so that we are consistent with the units. So instead of 100 grams of water, we're going to actually write down 0.1 kilos. The specific heat of water I've just written over there. And the temperature change is going to be 37.65 minus 20.24. Okay, putting that into a calculator, we get 7,277 joules, which works out to be 7.3 kilojoules. But whenever we're working out the heat of combustion, we need to work it out per mole of fuel. So we now need to work out how many moles of methanol burns. So the way we can find that out is we've got the mass of the methanol and we've got the formula, so we can work out how many moles that corresponds to. So first step, we're going to work out the molar mass of methanol. So carbon is worth 12.01. We've got 3 lots of hydrogen plus 1 lot of oxygen and another hydrogen. So that works out to be 32.042 grams. Okay, now we're in a position where we can work out the number of moles of methanol by doing mass over molar mass. Okay, and the last step, to work out the heat of combustion, we're going to do Q over N. Okay, remember, as always, you don't round off any of the values until the very last step. So rather than just typing in 7.3, make sure that you use the value that you've saved in your calculator earlier. So the final answer that I've got is 661.58 kilojoule per mole. Now, if the question is asking us to work out the heat of combustion by definition, the heat of combustion, that's the amount of heat that is released when 1 mole of fuel is burnt. So since we've been asked for the amount of heat released, that value can remain a positive number. Now, if the question is asking us to work out the enthalpy of combustion, the enthalpy of combustion, that's a change in heat per mole of fuel. And in this case, because heat is released, that's going to have to be a negative value. And so that answer would be minus 661.58 kilojoules per mole. The other type of calculation you might have to do is one where you work the other way around, where this time you've been given the heat of combustion and you've got to work out the amount of heat that's released when various amounts of fuel are burnt. Okay? So in question A, we've been asked to write an equation that shows the complete combustion of alcohol. Okay, so that's the equation for the complete combustion of ethanol, and remember that the products for complete combustion are carbon dioxide and water, and we need to make sure obviously that the oxygen is balanced. Alright, now we've been asked to include the delta H value. So delta H is going to be minus 540 kilojoules per mole, and again, because heat is released, we need to include a negative sign. Okay, for part B, the first part of the question, we've been asked how much energy would be released if 10 moles of ethanol were burnt. Now, 540 kilojoules, that's the amount of heat released if 1 mole is burnt. So to work out the amount of heat released when 10 moles of ethanol are burnt, we just simply do 10 times 540. So that's going to be 5,400 kilojoules. Okay, for part 2 and 3, same sort of idea. So instead of multiplying by 10, you'll be multiplying by half and by 0.63 respectively. Okay, where we get to question 4, this time we haven't been given the number of moles, we've been given the mass. So what you'll need to do first of all is to work out the number of moles that this corresponds to. So as previously, first step is to work out the molar mass. Now that we've got the molar mass, we can work out the number of moles. And the final step is to work out the amount of heat that is released, so that's Q, by multiplying the number of moles by the heat, the change in heat. So the number of moles is 0.109, and the amount of heat released when 1 mole of fuel burns, in this case, is 540. So that works out to be 57 kilojoules. Okay, so now you've got lots more of these questions to attempt in your OneNote, so give those questions a go.